All right, today we're going to wrap up Chapter 3 by taking another look at finance problems, some that we've already done, and then a look into a few that we haven't done yet. The first part we're going to look at here are the ones involving compounded interest. And so when we have compound annual interest, we are basically using our growth formula. We normally have used a T here for time in years. So the formula that you are used to is A equals P times 1 plus R to the T. That's if it's compounded annually. Okay. However, if we compound N, or in this case, K times per year, our formula becomes a little bit different. We divide the rate by K and we multiply the number of years by K, so that it's compounding not just by the number of years, but however many times we're doing it per year as well. In the past, we've had an N here in that formula. It's the same idea. And then we have our compound continuously PERT formula, principal times E to the RT. Okay, so a lot of these, we've done these types of problems before. For example, this one says we're going to invest $5,000 at 5% annual interest, which means we'd be taking that principal times 1 plus 0.05. We're just going to call that what it is right away, 0.05, taken to the T, but we just want to know what it is after 10 years. If they were asking us for a model, or if we needed to graph this for some reason, we'd leave it as a T. But since we just want to find one value, I think it's okay for us to plug that in just as we see it. We're going to get about $8,144.47. We're going to round all our answers to the hundredths because we're dealing with money here. If we're compounding monthly, okay, now we're using our principal. Now we'll just fill in things in right away. We're going to invest $500, 9% interest compounded monthly is going to look like that in our growth factor. And since we're compounding monthly, we're going to take T times 12. So this would be the model here, 12T. Okay, but what we want to do is just answer one question. What is it 12 times a year? So, what is it 5 years later? So T we know is going to be 5, and we can make this 12 times T, 12 times 5, which is going to be 60 right away, just because we're finding that one value. This ends up being approximately $782.84. I really recommend this is one of those times if you have a new calculator where you can put fractions in, you can use that template. Otherwise, this is a time when if you wanted to just calculate your base by taking 0.09 first divided by 12, adding that to 1. Okay, there's your growth factor right now. If we were to just take this to the 12th right now and compensate for that 12 times per year, if we were to just take that to the 12th right now and leave this as to the 12T, that would be what this would be as a rate if we were compounding it annually. All right, so just as a little side note here, we could simplify this to 500 times 1.09, fix that, 1.0938 to the T, because I took that to the 12th. And now this would be as if it were an annual interest. This is something that we're going to talk about a little bit later, actually, in this this problem right next to it here, where it talks about what the annual percentage yield is. What would that same scenario be like if we had an annual interest or compounded annually instead of 12 times per year? This would be the equivalent interest rate in this case. That 9% becomes 9.4%, just about, by compounding it 12 times per month. so that we could use that. And then when we took that to the fifth, because it's after 5 years, and then multiplied that by 500, so we get that same answer right there, that we got by plugging it in fully. Third example here, a little bit different. They're asking how long will it take for something to happen. So we're going to invest 500. We're looking to make 3,000. So we're going to say that 3,000 is our ending amount. That's going to be 500 times. It's really that same scenario that we had up before, which was we could use the 1.0938 to the t, or without taking it to the 12th, you could use the I have it up here, the 1.0075 taken to the 12t. You could use either thing there. I'm going to just say 1.0938 to the t. And then when we're solving this now, I'm going to use this value that I have stored in my calculator. In fact, I'm going to go back up and grab it and get that as a value that I can use in my next problem there. And then we could start solving for t by dividing by 500 and saying 6 equals 1.0938 to the t, and then we could switch forms. Log base 1.0938. You can round that there if you want, but I would use the number that's stored in your calculator and your calculations. This would be log base 1.0938 of 6 equals t. Okay, and then that's going to end up giving you about 20 years by using the change of base formula. So we take, actually I'll take the one extra step to do change of base, log of 6 over log of 1.0938. Just we'll show that so that we can show the change, that we know the change of base formula. Okay. If you look at my answer key online, if you look at the answer key for the notes online, I actually left this as the 1.0075 and then left this as 12t. So I didn't take it to the 12th. And then I went through this process here when I switched forms. I still divided this first and got 6, so I'll just do that right away. Divided by 500 and got 6, and then when I switched forms, I had log base 1.0075 of 6 equals 12t, so then t would equal 1/12 of that change of base formula. Log of 1.0075 over log of 6. I got that backwards. Make sure you get your base in the basement. Log of 6 up on top. And both of these, this calculation, the one that I just had before, resulted in the exact same value. It's about 20 years. All right, example 4 here. I'm going to skip example 4. It's basically like example 2. We're just looking to double the money, so to go from 500 to 1,000. So you, just as a quick setup here, you'd have 5,000 as your final, 500 to start. We're going to look for the annual interest rate here. So actually, we'll set this up here, I guess, a little more. 1 plus. We don't know what the annual interest rate is. We know it's compounded quarterly, so I can have a 4 here, a 4 here, and we're going to have 10 years, so 4 times 10, I'll just put a 40 right there. Okay, now this time we don't need logarithms because what we're solving for is right there. We would divide by 500 first, take the 40th root, or take it to the take both sides to the 1/40th, so 2 to the 1/40th. To get rid of that, power of 40 right there. That would equal 1 plus r over 4, and then we would subtract 1 and multiply by 4 to get our final answer there. But no logarithms needed there because it's not in the, our variable is not in the exponent. We have a compounded continuously problem here. It asks us to find a whole bunch of values, which would probably be best to just put it in your calculator and get the values from your table, but you got to come up with the model anyway. So here's the start. We know it's continuous, so we have to start with PERT. She's going to invest $100 at 8% interest. So we have 0.08, and it says find the value of her investment at the end of each of these years. So we put a T here, we put this in our calculator, and then just get the values off our table for 1 through 7. We'll just do 1 as an example here. Let's say they were just asking us for 7. So you put a 7 in for T here, so times 7. And we should get about 175.07. Let's just type that in here real quick. 100 times e to the x. So I go second natural log. There we have our 100 times e to the blank. And in there I'm going to put 0.08 times 7. Make sure you're using enough parentheses if you don't have these nice templates. And there's our 175.07. Okay. Make sure if this were like a quiz, we'd be answering with the dollar symbol. Actually, if it's your homework anyways, we'd be putting a dollar symbol for the money that it's representing. All right, our last thing here, annual percentage yield. Says, I'll just go through this paragraph here as an intro. A common basis for comparing investments is the APY. That's a percentage that, if it were compounded annually, would yield the same return as the given interest rate with the given compounding period. So the idea here is, I'm just going to come over here and take a look at this. If you have room maybe to write this right here, I'm just going to write a little bit bigger. But the idea is, we're going to take some principal, and in a very simple annual interest, we would just take 1 plus whatever the rate is. So we can have R there for rate instead of X. But this is the rate right there. Okay. This is going to be after 1 year, so I'm not even going to bother putting anything in the exponent right there. We're trying to find out when would this equal the same principal, okay, the same amount invested, but this time we're going to take that annual interest rate, and I'm going to use R here for whatever that interest rate is, divided by N or K or whatever you're calling the number of times it's compounded, taken to the K. And again, this is after 1 year, so I'm not going to put T because it's just 1. Well, so in other words, what value of X, what would this rate have to be to be the same thing as that idea right there? Well, the first thing I'd like you to notice is we could divide both sides by P. We don't even have to take into consideration what the principal is. Right? We can then solve for X if we know what the rate is compounded at how many times, which is actually the same thing there. This is the number of compounded times in a year. This is the rate. Okay, if we know those two things, we can solve for X then. And again, the principle is the same in either case, so we don't need to worry about it. So in this example right here, she's going to invest $2,000, Ursula is, in the Crab Key Bank at 5.15% annual interest compounded quarterly. All right, so we know that 1 plus X, so I'm just taking that equation that I just had right over there, 1 plus X equals 1 plus R over K to the K. Right? And we could start by putting a P on the outside of here and a P on the outside of there. But we're going to put $2,000 in for both of those, and they're both going to cancel out anyways. These are both going to cancel out no matter what. So we have this 1 plus X equals 1 plus R over K to the K. Now we're solving for X. So actually what I'm going to do right away is subtract 1 over to this side. And I want to put the values in. What would that interest rate need to be in this annual interest if it were a 5.15 or 0.0515 compounded quarterly, which would be divided by 4, taken to the fourth, and then minus 1. Right. Again, if you've got templates, want to type it in just like that, you can. Otherwise, I would take that quotient first, and then add 1, and then take it to the fourth, and then subtract 1 last. as order of operations there. So 0.01515 divided by 4. Then we're going to add 1 to that. Then we're going to take that to the fourth. And then we're going to subtract 1. And we get 0.0525. So that's what the annual percent would have to be if it were only compounded annually, okay, instead of being compounded 4 times a year. So in other words, it would have to be a higher interest rate if it was only compounded annually. Because when you compound more times per year, a smaller interest rate can give you the same amount as if you were compounding annually. All right, the last thing we're going to take a look at here in 3.6 are what are called future value and present value. We're going to be using our calculators for a lot of this. We're going to look at the formulas that they give us, but then end up using our calculators for a lot of it. We're going to use what's called the TVM app on your calculator, which is under the finance. So go to applications, go to finance, and it's the TVM solver. Is actually what we're going to use. Looks like that. Okay, that's the thing that we want there. And I think I actually have the spot on your notes already down here where we're going to end up using it in a second. So that's how you get to it again. You go to, let me quit out of here and show you again. You go to apps, and then to finance, number 1, and then to the TVM solver, which is number 1 there. All the new calculators, all the new TI should have this. If you have an older one, maybe it's time to upgrade. No, I'm just kidding. You can use the formulas that we have here as well, and it's probably not that much longer, to be honest with you. You might have to do a little bit of algebra to solve for a variable to begin with. Otherwise, it's a lot of just plugging in values and finding out one of the missing values. So to start with, let's look at example 8 right here. It says at the end of each quarter year, Emily makes a $500 payment into the Langenhan Mutual Fund. Her investments earn 7.88% annual interest compounded quarterly. What will be, if her investments earn that, what will be the value of Emily's annuity in 20 years? So we want to find out the value of this annuity if after 20 years she makes a $500 payment, and she's making that $500 payment at the end of each quarter year, so 4 times a year. So understand the difference here from what we have been doing is in all of our simple interest problems we've done so far, even if it's been calculated or compounded N or K times a year, we've only done one principal investment. Now we are talking about doing a consistent investment a certain number of times per year. Okay, so the future value is what we're looking for here, the value of this annuity. And we're going to use this formula here, which is explained in the blue box there, making an initial investment, periodic payments of R dollars, which is why they use R instead of P. Well, I don't know why R, but the reason why they don't use the P is because when we use P, that's like we're making one payment in the beginning. This is going to be periodic payments of R dollars. Okay, the interest rate is I, and you are making N equal periodic payments. So in this problem, N is 20 times 4 because we are going 20 years, and it's doing it every 4 years. Okay, so and our R value is 500, and then the interest is as if we were calculating it compounded quarterly. So we take the annual interest and we divide it by 4. All right, so I'm going to write that off to the side here because that's pretty important. I is going to be whatever the annual interest rate is. Then we got to compensate for the fact that it's done quarterly, so we're going to divide that by 4. And then N is how many times overall that's been calculated, or we've made these payments. So 20 years, 4 times a year. So N is going to be 80. So the future value is going to be 500, that's my R, and then 1 plus I, which is 0.07884 over 4, and that's taken to the 80th, and then we're going to subtract 1 from that, and that's all going to be over I, which is the 0.07884 over 4. Okay, so there's a lot going on there. Definitely want to use one of the fraction templates if you can, or take it piece by piece, starting with the inside of that guy probably, maybe storing that value since you need it again down there, and then you can divide by that value. When you do end up calculating this, actually, let me do that here real quick. Oops, not here though. I don't want to do it here yet. So I'm going to calculate that I value first. So I have 0.07884 divided by 4. I'm going to store as I, alpha I. Okay, so that's stored that, although 0.01971 is not that hard. I'm going to write that down. Oops. 0.01971. We could probably just use that too. But now what I'm going to do is I'm going to take 500 times, and get my fraction template in there, and then in the numerator we have 1 plus, I'm going to use that I that I have, alpha I, or you could just type in 0.01971. That's going to be taken to the 80th, and then we're going to subtract 1, and that's all happening in that numerator, and that's all going to be divided by I, alpha I. And we should end up with about 95,483. We're off there. I'm wondering if I... Oh, I don't think I should add that 4 right there. Divide by 4. All right. I don't think I should add that 4. I was going a little too quick and added an extra 4 in there where I shouldn't have. Let's see how big of a difference that makes here. 0.788 divided by 4. 0.0197, that extra 1/10,000th there. If I store this as I again, all right, now I'm going to go back up and calculate this. See if that makes a difference. There we go. That's what I was expecting to get. So that 1/10,000th compounded 80 times overall made a difference of less than $100, about $50. That's kind of an interesting mistake to make there, though. That had that big of an impact. So that future value is going to be 95,483.39, making $500 4 times a year at 7.88% interest for 20 years. All right, let's take a look at what that would look like on the app on our calculator. So using that TVM app. So here's what we're going to do. I'm going to just write out pretty much what it's going to look like in the end. So we have actually, what I'm going to have you guys do is just copy down here what is going to end up being on the calculator here. So let's go back to that app. So apps, finance, TVM solver. All right, so here's what we want to put in for this example that we just did. We're going to have a total of 80 payments, 20 years, 4 times a year. We're going to put in I. You put in I as not as a decimal. That's why they already have the percentage symbol right there to say put this in as the percent. So 7.88. And then we're going to leave this as 0. Our payment, this is where things are a little goofy. You have to make this a negative. Okay, so I'm going to write this down here. We have 80 I 7.88. PV is 0. There was no value to this before we started. There was nothing in this account when she first started, so the present value is nothing. So she started from scratch. And then the payment is negative 500. Okay, and then leave this as 0 for right now. We're going to come back here in a second. This is kind of the important one. This is what we're looking for, right? Payments per year, we're going to leave this as 4. It's compounded 4 times per year. Okay, and we want to leave this as N because it's set at the end of each quarter. Okay, now here's what we've got to do. You come back up to, let me finish writing this here. P, Y is 4, C, Y is 4. Payments and the number of times is compounded, and then the payment leave as end. Okay, now you want to go back up to FV for future value, and you're going to type in alpha solve like this. So you go back up there and highlight that 0 that's right there, and you type alpha, and then you hit enter for solve. Alpha enter. And there it gives you the answer, 95,483. Okay, so a couple of important things. Make this a negative, all right? And then leave this blank and go back or leave it as a 0 and go back and hit alpha solve over it, and then leave this as a interest percentage, okay, not 0.0788, not as a decimal rate. All right, let's take a look at the next one here, the present value. So we're going to be purchasing a truck here for about $18,500. We want to know what the monthly payments are. The 4-year loan, we're going to put $2,000 down. The annual interest rate is 2.9%. All right, so let's take a look at our formula here for the present value. Present value is your equal payments of our dollars, which is really what we're going to be looking for here, because we want to know what our monthly payment is. So actually, let's solve for that R first right here. If I wanted to get R by itself, first what I'd have to do is multiply that P by the PV by I, and then what I'd have to do is divide by this stuff right there. So I know that R is going to equal that PV times I divided by 1 minus 1 plus I to the negative N. All right, and now if I take that, let's write it again up here. R equals PV times I over 1 minus 1 plus I to the negative N. And we're going to put in all the things that we know here. Our present value of the truck is $16,500. Okay, now we got to do some calculations here again with I. The annual interest rate is 0.029, but we're going to be making monthly payments. Okay, so we're going to spread that interest rate out by dividing it by 12. So we have 0.029 divided by 12 for I. And then we have 1 minus 1 plus 0.029 divided by 12 to the negative N. N, again, we're going to be making monthly payments for, how many years was it? 4-year loan. So that's going to end up being 48. So we have negative 48 right there. Okay, and that would tell you what that payment would need to be. What we end up getting when we type this into our calculator, and I'm not going to take our time with that right now, is $364.49. What I'd like to do is get to that app on your calculator and show you how to do it on there. Okay, and I'm okay with you either way. If you want to do it by hand like this, or if you want to do it on the calculator, I'm okay either way. Let's take a look at that here. So we have N, we have I, we have PV, You could probably think right now about what we need to put in differently than what we did before. And then the payment. Which we're just going to leave it end again. All right, so let's go back up here and put in our values to find out what Carlos's truck payment needs to be. He's going to be making 48 total payments overall, excuse me. The interest is going to be a 2.9% interest rate. Right now, the present value, it's not zero. This truck is worth $16,500. Okay. Now the payment, I think now this will make a little bit more sense why we made that negative before. Okay, I'm gonna leave this. I'm just gonna put a 0 in for right now because we're gonna come back up and that's what we're looking for. That's what we're gonna hit alpha solve on later. But the reason why we make this negative is because it's gonna be chipping away at that value. All right. All right. Future value. We want to pay this truck off, so we want it to be 0. Payments per year, 12. Try that again, 12. And then it's going to be compounded 12 times a year. All right. So let's go back up to what our payments need to be in order for us to go from 16,500 down to a future value of 0. So we hit alpha solve here, and we get that same value, 364. And we see that's negative because we want to be knocking these payments off of that 16,500. Okay. So we had 48, we had 2.9, 16,500. Here's where we hit alpha solve. And then we had 0, we're paying it off, 12 and 12. And we ended up getting our answer, same answer as before, $364.49. Again, I don't care which one you use, but there is, if you use the calculator or if you do it by hand, but that is how you would do future value and present value.